Okay, so this video is going to finish the review guide for sections 1.4 and 1.5 in Algebra 2. This is from the class lesson that we did on the 15th, Thursday. So once again, your idiot of a teacher has forgotten to bring her pens home, so I'm going to try to do this with my finger. But I'm going to start on the second page for the sake of the students that were in class today. Anyone who missed class, just stay on the video and I'll go back to the beginning and finish through that. Hopefully it will behave. But on the back side of the review guide, I'm covering some of the word problems on applying the equations that we've learned. And so this first one is an interest question. So again, it's the principal times the rate times the time equals the interest that gets accrued on an account. And in this case, we have two different accounts. So we have a company who's making two investments. Their total principal is $152. So that's how much money they take and invest in these two separate accounts. So one account is yielding 15% annually. I don't know what universe they live in that they get this much back in interest, but lucky for them. But one is 15% and one is 21%. So for those of you that like to have the box, we have, so let's see here. I'm going to need some space. So this is the principal. Yeah, I'm going to need more space than that. Let's see here. Principal is going to be a bit large. And then the rate is not too bad. The time is the same, although this one is a little bit different in the sense that it's only for a half a year instead of a whole year. So we actually do have to include a time of 0.5. But this will be the 15% interest and this will be the 21% interest account. So there's principal times rate times time equals the interest, which is those three multiplied times each other. So we're asked to find how much is invested in each account. So how much is invested at each rate. So it's the principal that we're being asked to find. So I'm going to set the principal for the 15% account to X. And then the total investment is 152,000. And so whatever's left in the, so sorry, this is so messy. So the first one is X. That's how much is invested in the 15% account. And then in the 21% account is the total, which is 152,000 minus whatever was invested in the first account, the 15% account. So that way we're only using one variable, but we have two different definitions for principal, so we can find out how much is in each. So the first one, this is 0.15. Ooh, it's awful. And then this one is 0.21. So we've converted our percentage interest rate into decimal. And then the time is 0.5 because it's half of a year. So we'll keep that as a decimal. So the interest for the 15% account is just 0.15 times 0.5 times X. And then this one is 0.21 times 0.5 times, oh, this is gonna be hard. Okay, 152,000 minus X. Okay, so in this case, we have the interest of the first account plus the interest accrued in the second account equals our total interest. So that should be a T, not a 2. There we go. Interest total. So all we do is we take the interest in the top box plus the interest in the second, and it equals, we know how much their 6-month income is. So again, that's that half. So let's say you didn't want to use that 0.5. You could just double their yearly income. You're going to get the same answer. I'm going to keep it in here because I'm just working with what we were given in our word problem. But we can set that to equal 13,350. So we have, and I'm going to go ahead and do the math here. So the 0.15 times 0.5 is 0.075 times X plus 0.21 times 0.5 is 0.105 times 152,000 minus X, and that equals, let's hope I don't run out of room, I probably will, 13,350. All right, so I am going to get rid of the decimals here. So I'm going to multiply both sides, this one and the 13,350 times 100. I'm so sorry, this is so messy. No, times 1,000, right? Because we have that 5 here and here are both in the thousandths place. So we're going to multiply that times 1,000, and we end up with 75x plus 105 times 152,000 minus X equals 13350, and then I'm adding 3 more zeros. 1, 2, 3. 13,350. 13,350,000. Okay, so once I distribute this 105 into my 152,000 minus X, I still have 75X plus, hold on, let's see, 152 times 105 is 15960, and then I also have those last three zeros, 0, 0, 0. So 15,960 minus 105X, and that equals the 13,350,000. All right, so at this point, you are going to combine like terms. So we have a 75X and we have minus 105X. So we're going to combine those. And to save my space, I'm also going to subtract the 15,960,000 from the 13. So I'm going to do both of these at one time. So go ahead and subtract that. 960,000, and this is minus cat, go away. All right, and so that will give me 75 minus 105 is a negative 30X, and that equals, let's see, cat, go away. Okay. Sorry, let me double check myself. 13 minus, so that's 2. Let's see, 2, 6. No, I gotta, let me check myself here. I didn't do that on my example. Okay, so 0, 0, 0. 6 take away 5 is 1, 9 take away 3 is 6, 5 take away 3 is 2. And it's negative because it's 15.9 million minus 13.35 million. So that leaves us with negative 2,610,000. But we're taking that number and we're dividing it by our negative 30. So this is a negative divided by a negative. There, negative 30. So we end up with X equals 87, should be 87,000. Yeah. 87,000. So that means that it's 87,000 in our X account at 15%. So this is 87,000 at 15%. And then when you do the 152,000 minus 87, so this is 15%. 21% account has 65,000 because that's what's left that they invested in the 21% account. double check myself here. So that's your final answer. 15% account got 87,000, 21% account got 65,000. All right. So this next one is, again, very similar to what we had in our homework. We have, we're determining the dimensions of a, in this case, it's fencing. So we're going to go ahead and say it's a rectangle. We have a length. That doesn't look like an L, but you know what I'm doing. Length and width. So our original equation for this is the perimeter, which is 2 times the width plus 2 times the length equals the perimeter. Now we want the perimeter in this case to be 110 feet. He wants to use all of his fencing. So we also have our length in terms of our width. So we can redefine length as length equals 1.5 times the width. So we're going to plug that into our variable L so that we end up solving the width. And then from the width, we can go back and solve the length. So this is 2W plus 2 times 1.5 W equals 110. All right, so once we have that, we can distribute that 2. And so we end up with 2 times the width plus this 2 times 1.5 is 3 equals 110. And then we combine like terms. 2 plus 3 is 5. So 5 times the width equals 110. And we divide both sides by 5 and we find a width of, 5 goes 20, was it 22? So the width needs to be 22 feet. And then the length is 1.5 times 22, which is 33. Just another half of that. So the length is 33 feet, the width is 22 feet. And that's it. Okay. Also, for those of you that were in class, I am going to go back and solve that fraction equation by eliminating the fractions. So if you want to stay for that, I can go ahead and do that next. So I am kind of moving around, sorry. So let's go ahead and look at these. Let's go ahead and look at this first. All right, so for this one, we have 1/5 times x plus 2/3 minus 1/4 times 3x plus 7 equals 1/3 times 2x minus 6/5. So 60 is the only number, or yeah, the only number that both 5, 4, and 3 are a factor of. Whoa. Yeah, I figured you could do that. Okay, so sorry, draw with touch. So 60 times 1/4 and 60 times 1/3. So 5 goes into 60 12 times. So this ends up being 12 times x plus 2/3 minus 4 goes into 60 15 times. 15 times 3x plus 7. And 3 goes into 60 20 times. So times 2x minus 6/5. Now, the nice thing is, though, we are distributing this 12. I'm going to use the arrows for the first one. And then we distribute the 15 in, no fractions there, and we distribute the 20 into the 2x minus 6/5. So you'll notice that 3 is a factor of 12. So we can reduce that 2/3 to a whole number. And then 5 is a factor of 20. So we can also get rid of that negative, that 6/5. The important thing is to remember we are including the negative with this 15 here. So the 3x and the 7 are both going to become negative numbers. All right, so this becomes 12x. Now, 12 times 2 is 24, divided by 3 is 8. And this one, negative 15 times 3 is negative 45x. And then negative 15 times 7 is negative 105. And then over here, 20 times 2 is 40, so 40x. And then 20 times 6 is 120. Divided by 5 is 24. So I know that's a lot prettier than the fractions we were left with in class. So sorry about that. Y'all know who to blame. Okay, so let's combine like terms. So we have a 2x, we have a negative 45x. Over here, we don't have to do anything on the right side. And then we also have a positive 8 that we need to combine with a negative 105. Okay, so we're going to end up with quite a few negatives, but 12x minus 45, we know our answer is going to be negative. 45 minus 12, double check my math here because we know I'm a special kind of idiot today, is 33. Right, yeah, 33x minus, and 105 minus 8 is 97, right? 5, 6, yep. All right, and that equals 40x minus 24. All right, so at this point, it's pretty simple. We're just going to combine like terms. We know we're going to end up with a negative regardless because the answer we got earlier was -1. So I'm not going to worry about trying to keep things positive because eventually it's not going to be. So I'm just going to go ahead and subtract this 40x from both sides. How much room do I have? Oh, I'm good. Okay. So when we do that, we end up with, this becomes negative 73x minus 97. Those cancel out and that becomes negative 24. All right, so now I add 97 to both sides. And these are unlike, so we are subtracting and our answer is going to be positive because the 97 is the larger value. So we have negative 73x. And when we do the math here, we discover that this equals a positive 73. 7 take away 4 is 3, 9 take away 2 is 7, yep. And so we divide both sides by negative 73. And we end up with x equals -1. Okay. All right, since I'm here, I'm going to go ahead and do the decimal one as well. But for those of you that were in class, you should be good at this point, unless you would just want to watch me work through them again to make sure that you've got everything written down on your review guide for tomorrow. All right, so in this case, we are getting rid of our decimals first. So we will multiply both sides times 100. So like I said in class, this does not, you are not multiplying anything inside the parentheses, the inner parentheses times 100, only the coefficients on the outside. So these three get multiplied and then that 0.25 gets multiplied times 100. When we do that, that gets rid of our decimals and we end up with 25 times 3a minus 5 equals 40a minus 300 times 0.55a plus 2.5, those stay, plus we got rid of that 0.25, so this is 1,000. Ooh, stop it. Oh gosh. 1,025. There we go. Okay. All right, so now we distribute. 25 gets distributed in here, so it's times 3a and times -5. So that becomes 75a minus 125 equals 40a minus 300 times 0.55 is a 165a, and then negative 300 times 2.5 is not an addition. Is negative, what was it, 275? No, that's after I combine it. Oh, negative 750. There we go. That's right, 600 plus 150. And then we still have that plus 1,025 there on the end. All right, so now we're combining like terms. These guys are constants. And then we also have two like terms here. The left, the left side is as simplified as it gets. So we can just leave that 75a minus 125 equals 40a minus 165 is going to be negative. So 165 minus 40 is 125a. And 1025 minus 750, that's still going to give us a positive 275. All right, and now we're back to the basics. We just combine like terms using the addition property of equality. So we can add 125 to both sides. And we end up with 200a minus 125 equals 275. Then we add 125 to both sides. And we end up with 200a equals 400. So hopefully at this point, looks pretty easy, pretty simple what your answer is. Divide both sides by 200, those cancel each other out, and a equals 2. All right, so that's our similar problem, but with decimals instead of fractions. Okay, so now back to the beginning. Whenever you're asked to state the property of equality that is demonstrated by a statement, so here we have some statements. The first one says, if 132x plus 12 equals 9x minus 7, then 123x equals negative 19. So what property have we used to go from the first step to the second? And that is an example of the addition property of equality. Now in the second, we have 3 times 2x plus 4 equals 28. If that is the case, then 6x plus 12 equals 28. Then hopefully you can see that we have just distributed that 3 into the 2x plus 4. And so this is an example of the distributive property. Distributive, that's what that says. Okay, and then C, if 2d plus 21 divided by 7 equals 9, then 2d plus 21 equals 63. So what we have done is we have multiplied both sides times 7 to eliminate our fraction on the left side. And so this is an example of the multiplication property. Okay. And we just did those big guys. So let's look at the literal equations. No, these are extremely intimidating and confusing for a lot of people. So let's work these. So in this case, we want to isolate the variable h. Unfortunately, it's just sitting right here. So this one's pretty simple. Remember though, when you're trying to move your terms around in a literal equation, you use reverse order of operation, similar to what we would do if we were just solving. So reverse order of operation. So you end up with the h on one side of your equal sign and everything else correctly placed on the other side. So reverse order of operation, currently to h, we are multiplying 2l plus 2w times h, and then we're adding 2 times l times w to it. So we would undo the addition first by subtracting 2lw from both sides. And 2lw is in no way is that a similar term to s. So you have to keep them separated by that subtraction sign. Make it look like an L instead of a 1. Okay. And we're left with 2L plus 2W times H. So because H is just being multiplied times this expression, we can divide by that expression to isolate the H by itself. These end up canceling each other out. 2L plus 2W. And we're left with H equals S minus 2LW divided by 2L plus 2W. And that is the equation set up to solve for H. All right, this one has a few more steps, but still just same thing. The one thing you need to remember is that for this one, because we're isolating L and we have L right here inside of a parentheses, but we also have it outside of a parentheses. So we're going to need to distribute the H into the 2L plus 2W. Then we're going to need to distribute out the L from the two expressions that contain it in order to isolate it completely. So let me show you what I'm talking about here. Draw with touch. Okay, so first we distribute the H and we end up with S equals 2 LH plus 2WH plus 2LW. Now we have this term here and this term here that have that L. So what we can do is, well, let me just situate them. You can use the commutative property of addition to put things with that, put that L term together. So I'm going to move this so it's 2LH plus 2LW plus 2WH, because I don't really need to fold that WH right now. All right, so within these two, I can then extract the variable L using the kind of a reverse distributive property. And I end up with S equals parentheses, what's left? 2H, because this is L times 2 times H, which is the same thing as you have above, 2 times L times H. Same thing, still works. Plus 2W plus 2WH. So now I've got the L sort of extracted from the terms where it's mixed with a coefficient and other variables. And so it's looking a little more similar to what we did in part A. So now I use my reverse order of operation, 2WH subtracted from both sides. All right. And I end up with S minus 2WH, 2 times W times H, equals L times 2H plus 2W. And so now I can divide both sides by the 2H plus 2W. And then I am left with just my L, 2H plus 2W. So these cancel each other out. And I'm left with L equals S minus 2 times WH divided by 2 times H plus 2 times W. And we're done. Okay. So again, we saw something like this in our homework that we worked through yesterday. Find 3 consecutive odd integers whose sum is -75. So again, you have to remember consecutive means it's right after the other, but we are also odd numbers. So if X is an odd number, then the next consecutive odd number is X plus 2. I'm just going to do that because it looks there. And then the one after that is going to be X plus 3, not plus 3, but word of mercy. Oh, brain. 4. And that needs to equal -75. All right, so now we can combine like terms. We have an X plus an X plus an X. We have 3X and a 2 plus a 4 is 5. So 3X plus 5 equals -75. We are subtracting 5 from both sides. So this is 3X equals, why am I like this, guys? Seriously, that does not equal 5. Just making up numbers at this point. All right, 4 plus 2 is 6. There we go. And 75 plus 6 is 81. So 3X equals -81. We divide both sides by 3. And I'm just going to move it over here. X equals -27. So if X equals -27, the next number is -27 plus 2, which becomes -25. And then our other number is -27 plus 4. So again, unlike sign. So we subtract, but it stays negative. That becomes negative 23. So just double check what you're given and what you're, do the work if you need to see negative 27 plus 2 and negative 27 plus 4, so that you know the number digits are decreasing in order. And so you don't say, okay, it's negative 27, so negative 27 plus, and then negative 29 and then negative 31, because then you would be wrong. And again, check yourself. Do the sum of 27 plus 25 plus 23. If you do that, you'll get the answer 75 and you'll be good to go. Okay. I think that finishes it. It was not a whole lot. And I just did those. So yeah, okay. And that's it. So good luck, and I'll see you tomorrow. Thanks, guys.